Hello, everyone. I'm Qiu Pingyi, and from Texas State University. I'm very glad to present our approach, which is named Summary-Guided Incremental Symbolic Execution. Symbolic execution is an efficient technique for systematic path exploring. It doesn't execute programs with a concrete input, but with a symbolic input. Specifically, it generates a symbolic execution tree of the analyzed program. Each path of the tree represents one feasible path. However, the main limitation of symbolic execution is path exploring. That is, the number of feasible paths in a program grows exponentially with an increase in program size, and can even be infinite in the case of unbounded loop iterations. Incremental symbolic execution is proposed as an alternative to solving the scalability problem. More specifically, it won't explore every feasible path, but only concentrates on the paths which may be affected by the changes. In this poster, we propose summary-guided incremental symbolic execution. Its key idea is that it dynamically instead of statically identifies the paths that are affected by the given changes, and then compute the summary based on the explored paths, and then plots the unaffected paths based on the summary. This is the main analysis framework, which mainly contains 3 steps. The forward symbolic execution is similar to traditional symbolic execution, except that it collects affected variables along the path. In the backward path summarization phase, it analyzes each explored path backwardly to compute a summary for each branch location. Under 3 conditions, a path can be pruned by our approach. Consider this simple example. It contains only one change, which changes the operator from greater than to greater than or equal to. The following figure is the execution tree after some paths are pruned by our approach. First, these paths are pruned because they will never reach any change. Second, these paths are pruned because they only encounter their change at line 2, and the changed condition A is less than 0 is implied by the before unchanged condition A is less than or equal to 0. Third, the paths along this prefix are pruned after these paths are explored, because based on the computed summary of our approach, it finds that the different choices at line 10 are not related to any affected behaviors. We evaluated our approach on 2 subjects. The first one is TCAS from SIR with 41 verses, and the other one is GNU coital suits. We implemented our approach on CLE and compared it with CLE and DICE. To check the correctness of our approach and enhances the confidence in our implementation and experimental results, we checked whether our approach and DICE can identify the errors in each TCAS version caught by CLE. The answer is yes. For the effectiveness, on average, our approach reduced the explored instructions and paths to about 60% and 70% respectively. For efficiency, our approach needed about 61% and 28% more memory than CLE and DICE respectively, but our approach achieved about 61 times speed up over the other 2 approaches. To sum up, we propose a novel approach for incremental symbolic execution. Our experiments show that it's efficient in exploring affected paths and pruning the unaffected ones. Thank you for your attention.